We're looking at bivariate data and correlation in this video. We're going to be introduced to these concepts here. Firstly, before we do that, I'd like you to have a look at, consider this to be a little bit of a quiz, see what you think. So, 5 questions, in fact 5 statements, and the question is the same for all. For these 5 statements, which ones work? I.e., for the first one, does the height of the person depend on the mass of the person? So does the first correlate? Now that's a link to that word. In other words, does it have a definite relationship with? Does it depend on? Does the first one depend on the second one? Alright, so the first quantity, does it depend on the second quantity? For them, I'd like you to write yes or no. So for A to E, I'd like you to pause the video and read them all, and then write yes or no. Okay, so now that you've had a chance to do that, we've got the height of the person depends on the mass of the person. That might mean if you all of a sudden decide to overeat and gain a lot of mass, you're going to get taller. That doesn't work. It doesn't work like that. But if we reverse the direction, the mass of a person overall it does depend on the height. So taller people overall, if you sample enough people, taller people would have more mass. So if you reversed it, so you'd have to put a little statement, say if you read it in that direction, the second depends on the first, then it's true. Otherwise it's not true. Temperature and the life of full cream milk. Okay, well, read that way, it doesn't correlate because the temperature is related to the life of milk. It's the other way around. The life of milk is related to the temperature. That's true. If you leave your milk out in the sun, it's going to go off pretty quickly. So provided you read it from right to left, it's true. What about the next one? Length of hair and IQ. That's intelligence quotient, which some people believe is a predictor of your intelligence. The length of someone's hair affects their IQ. I hope not, because I don't have any hair and I feel I know something. What about the other way around? IQ changes your hair length. Ooh, I don't think so. So neither way, that doesn't work. Depth of your topsoil and the brand of car you own. No matter which way you look at that, they're completely unrelated. They do not correlate. They don't have a relationship. One doesn't depend on the other. Alright, that one's a big no. And years of education and income. Well, that's true. If you sample a large number of people with a higher income do tend to have more education. So that's true. Income is related to years of education. It's not the only thing that, of course, there's some outliers out there that have low education and high income. There's some exceptions, of course, but if we look at the trend for a large number of people, it's a very strong trend. So provided we read it as income depends on years of education, provided we read it in the correct direction, there is a correlation. So we had 3, provided we made the correct direction, the correct way of reading, we had 3 with a correlation and 2 without. Some important definitions to take note of now. So make sure you take note that this word bivariate, bi meaning 2, variate means there's 2 things that vary, 2 variables. So the 2 variables, for it to make any sense and be not a waste of time, they have to be related. Just like we said before, some of these things had a relationship and some of them didn't. So if we looked at the first, second and fifth ones, they would be probably suitable for bivariate data. So the height and the weight one, for example. A scatter plot is used. Oops, had an interruption then. Continuing on, a scatter plot is a graph, a suitable sort of graph on a number line. Basically, it's 2 axes with a whole bunch of dots there. So when we have one variable here and that variable there, you'll see dots there. And if they come close to approximating a line of some sort, it might be a straight line or some other sort of line, we can say there's some sort of correlation or some sort of relationship. So independent always goes there, and dependent variable goes on the vertical axis. Okay, so you need to work out what changes automatically, or what does the person controlling the experiment change, versus what gets changed. That should not be new work. Okay, so we've got scatter plot is a graph in which axes correspond to the two variables from the bivariate data. Relationship, which we saw previously, correlation and association are used. People like medical researchers, for example, they'll use that a lot. So type 2 diabetes is associated with a certain type of diet, for example. So these are important words. Let's look at some more stuff here. Types of correlation, we can see visually that that would be a strong and positive. So there's two adjectives there. Strong means that it's pretty close to a straight line function. It doesn't have to be a straight line. It has to approximate some sort of function or trend. This one approximates a straight line, like most of the ones you see will. See how they're not exactly on the straight line, but they're pretty close. There's not a lot of deviation. It's positive because the gradient is positive. So as it goes from left to right, it's going up. And as you know from your previous work, that's a positive gradient, so that's a positive correlation. This one here is pretty loose. You could, with not much confidence, put in a falling line, so that's a negative correlation, but it's weak. You've got lots of gaps with this data overall. It doesn't hug the line. This is a swarm of bees. No, it's not. It's basically no correlation. It's pretty much random data. There's no discernible correlation. Now, we've looked previously with box plots and 5-number summaries for outliers. A less mathematical way of identifying an outlier is looking at something that's clearly a long way from the rest of the data. So you could substantiate an opinion saying, yep, that one there, that's an outlier. Okay, it's isolated from the rest of the data. Let's have a quick look at an example before we finish. Consider the simple bivariate data set, X and Y. So Y depends on X. Alright, so as X changes, Y changes as a result. So we draw a scatter plot in part A. So we'll have X, the independent variable, along here, and Y, the dependent variable, along there. And we just plot those points like we do for Cartesian system. And so 13.2.1 is the first one. So 13 is there and 2.1 there. So that would be that point. And we continue on in that regard. So describe the correlation between X and Y as positive or negative. Alright, so as X goes up, Y is going down. Okay, so it's a negative correlation, negative gradient. Is it strong? Well, if we ignore the outlier, it's fairly strong, because even with my rough line through them, I could have drawn a better line, but those aren't very far away, except, okay, like we do with box plots, we can exclude or isolate the outlier if we need to, and doing that, we'll put it on the graph, but excluding it from the trend, it's a strong correlation if we exclude the outlier, and that is the outlier there in part D. So the outlier is the one that's at 6, 0.9.